Questions, comments, concerns before we begin? All right, well, just so we're all on the same page, the plan for today is um, pretty straightforward. Again, we'll start off like we usually do, open up the floor to Q&A, and then what we're going to do is run through one specific set of practice problems, which should get us more comfortable with both cap and trade and Pagovian taxes. This set of practice problems is on your Canvas page already, just in case you're having trouble with the screen share, or in case you want some of the available information to follow along on your own. In fact, let me go ahead and drop that link into the chat, but it's under week 4 example problems. So Christina, did you have a question?
Oh, I don't like I kind of get like the topics from like how can I say it? I don't understand the math of it, but I understand what it's doing. Like I understand what cap and trade is, and like I understand the tax, but I don't understand like what you did in like the example in the slides.
All right, so the plan for today is actually to go over a cap and trade example. So let's do that as a class and see if that helps clear something up. Does that work for you?
Mm-hmm.
And everyone else, any other questions before we get going? All right, so what I'm going to do here is share my screen. And all right. So let's just start with this example problem. And all we're doing today is running through the sort of 5 steps of this example problem. So I'll read it to all of us. Suppose that firm A and firm B both produce 80 units of pollution. The federal government, some regulatory body, wants to reduce pollution levels. We're given some marginal costs per firm associated with pollution abatement. The marginal cost for firm A is 50 plus 30Q, and that Q is the amount of abated units of pollution. The marginal cost for firm B is 20 plus 6Q, and again, Q sub A and Q sub B are quantities of pollution abatement by each firm. We as society also benefit from total pollution abatement. So we have a marginal benefit equation that we got from there. Marginal benefit equals 590 minus 3 total Q. Everyone with me so far? All right. And I've turned off my video, and because I'm sharing on this other screen, I'm not going to be able to see you. So if you have questions, just shout them out. But our first question is, what is the socially optimal level of each firm's pollution abatement? And we'll answer that together as a class. We'll go through the work together on this screen. But who has a sense of how we set that problem up? Keeping in mind that what we're talking about is this social optimum. And I can go back up to the given information if you want. But how do we set this problem up? Anyone have a sense?
Would we set the marginal cost of firm A and firm B equal to each other?
That's a great first step. So MCA equals MCB. And I'm going to make that a capital A. And just to punch everything together on this slide, 50 plus 3Q sub A equals 20 plus 6q sub b. Moving that 50 over to one side, we're going to see 3q sub a equals minus 30 plus, oops, sorry, I got this 6q sub b up on the wrong line. All right, so all we did was set our two marginal costs equal to one another, and then we moved this 50 over to this side of the equation. We're going to divide both sides by 3, and we'll get q sub a in terms of q sub b. So minus 10 plus 2q sub b. That's a great first step. So what we did was set the marginal cost of abatement so we set marginal cost A equal to marginal cost B. What is the next step? So it's good that we have the marginal costs equal to one another, but we were given some more information in that problem. And pretty much all we do in econ is equate marginal cost to marginal benefit. So in that problem, we were also given this marginal benefit function. So our next step is to set marginal cost for firm B equal to marginal benefit. And then we're gonna just to substitute in for QA and solve for QB. Questions so far? And we'll run through the math together right now. So if you've got a question, I can't see you right now. So if you have a question, just shout it out. But we've got that marginal cost for firm B, so 20 plus 6 QB. We also have the marginal benefit to society. 590 minus 3 QT. And we'll note that QT is total abatement, so it's QA plus QB. So we've set marginal cost for firm B equal to marginal benefit for society. And we're going to distribute that 3. In fact, it's a minus 3, so minus 3 QA minus 3 QB. Questions so far?
Can you go over that last thing?
What last thing?
After substitute QA and solve for QB, like everything after that.
Yeah, so we set, this is 2 steps of the problem. We set the marginal cost for firm B equal to the marginal benefit. But we also know a little bit about QA, which is QA equals minus 10 plus QB. And we know that the marginal benefit is for society as a whole. Does that answer your question? So this part of the equation right here is just the marginal cost of abatement for firm B. This part right here is just the marginal benefit for all of society. Remember, QT is total quantity abated, which is just the quantity that firm A abates and the quantity that firm B abates. So all we have here is the marginal cost for firm B set equal to the marginal benefit. You with me?
So are you taking the 3 from the QT and distributing it into QA and QB?
Right. So we have here 590 minus 3 times QT, but QT is QA plus QB, because QT, that T just stands for total, and A and B are the two firms in this society. You ready to move on?
Wait, so QA, QB. Oh, yes.
Okay, but from this equation up here, from setting our marginal costs equal, we can put QA in terms of QB. So this side of the equation that I'm typing out is just the same marginal cost for firm B, 6 QB equals 590 minus 3 QA we can write in terms of QB, minus 10 plus 2 QB, and then we have minus 3 QB. I'm just going to clean this line up real quick.
I'm sorry, I know you just kind of answered this, but where did 3A and 3QA and the 3QB come from?
You're talking about this line that I've highlighted right here?
Yes.
So we have the marginal cost for firm B equal to the marginal benefit.
Yes.
Marginal benefit is from our given information, right?
Yes.
Marginal benefit is given in terms of society as a whole.
Mm-hmm.
So society as a whole, the pollution abated for society is just the pollution abated by the two firms. 3QT, QT is total abatement, which means it's abatement from firm A and abatement from firm B.
Mm-hmm.
So here we have just that same marginal benefit curve, 590 minus 3QT. But QT, total abatement, is abatement from QA and QB.
Yeah.
So when we plug minus 3 times QA plus QB, we have to distribute. Minus 3 QA minus 3 QB. You with me?
Why would you distribute?
Why wouldn't you? You have
I don't
minus 3 times a quantity, and that quantity is a sum.
Let's see this. Okay.
So when I say distribute, I'm talking about the distributive property of multiplication.
Yeah, I get that. I just don't understand. Maybe I just don't understand how it's written out. Maybe that's what's
Certainly, it's a little difficult writing live on PowerPoint screen, but write it through on your own paper and see if you come up with the same thing.
Okay.
Substitute in what the total quantity abated is, and you should get the same thing.
Okay.
All right. So when we plug and chug with all this algebra, we should have 15 QB equals 600. and the quantity abated by firm B equals 40. So I'll let you guys take a minute on your own to go through these couple lines and see if you got the same thing. And if anyone wants to go over some of the algebra, we can do that. What I'm going to do here is put an asterisk because this is the optimal. So QB star. And one of the things that might be confusing here is I'm being a little loose with subscripts. I'm using lowercase rather than subscript, just because I'm typing live. But all these lowercase letters, imagine that they're subscript, if that helps. So from here, we can get QA star. We can get the optimal quantity abated for firm A. And that's from this equation up here. By setting the marginal costs of abatement equal to one another, we can get the quantity abated by firm A in terms of firm B. We got the optimal quantity abated for firm B, so we plug QB star up into our QA formula. So QA star equals minus 10 plus 2 QB. QB is 40. We got that already. So 80 minus 10, that's 70. You guys with me so far?
Yes.
Cool. Any questions? I know it's a little difficult doing math live on PowerPoint, but this is sort of the best thing I could come up with in the short term. Questions? All right. So here we have all the given information again. We already solved for the optimal level of abatement. Now we want to know how much total pollution there is. And the key thing to this question, how much total pollution is there, is this bit of information right here. Both firms, in absence of any policy, are producing 80 units of pollution. So how much total pollution is there? Well, there's 160 units of pollution in absence of any policy. And in the social optimum, and I'm just replicating the information from our last slide, so I'm not solving anything new right now. We solved in question 1 that each firm had a different optimal abatement function. Firm A optimally abates 70 units. Firm B optimally abates 40 units. That means the optimal abatement is 110. You guys with me? So total optimum pollution equals pollution minus QT, optimal abatement, 160 minus 110, and that's 50. Questions so far? So I'm going to stop sharing the screen real quick, and I'm going to come back on the camera. So what we've done is we've been given some information about 2 firms in a society that are polluting. We want to know what the optimal level of pollution they can abate is, given some benefit function to society. We were given that benefit function. So we were in a situation where these firms together were polluting 160 units total. We would like to get that pollution down to 50 units based on what these functions are telling us is best for society. Questions so far? All right. So if there aren't any other questions, I'm going to share the screen and we can keep going with the problem. And again, all we have here is that given information from the start of the problem. This is all the information we started with. Now this part of the work, and hopefully this helps clear up some cap and trade questions for you. Explain why it would be inefficient to give each firm an equal number of polluting permits if they weren't allowed to trade. So in other words, and I'm gonna go down. What we're talking about is pollution cap, but no trade. And I'll put that in all caps. So even if we could cap pollution at the optimal level, who remembers what that optimal level is?
Is that the 110?
110 is the optimal level of abatement. The optimal level of pollution is 50, but they're just inverses of one another. So it's 110 plus 50 equals 160. That was what they were abating, what they were polluting previously. So our optimal level of pollution is 50 units. All right. So if we gave each firm an equal number of pollution permits and they weren't allowed to trade, why would this be inefficient? So we already solved for the pollution optimum. That it's 50 units of pollution. So if we're permitting, each firm would get 25 pollution permits. You guys with me so far? Any questions?
No. Was it in the question, or maybe I just ignored, I looked over it, that said 25? Or did you just give a number?
Yeah, so we already solved for the optimal number of pollution that society would like.
Yes.
So if a firm is, if the government is giving out pollution permits, they're going to give it out at that optimal level of pollution. They wouldn't allow for pollution that they don't want. You understand?
Yes.
So if we've solved that the optimal number of pollution is 50 units of total pollution, in the question we're saying, why don't, if what we want is 50 units of total pollution, why don't we just say each firm is allowed to pollute 25 times? 2 firms, 25 each, that's 50. You with me? You with me?
Oh, okay, yeah, I get it. Yeah.
Okay. So we want to know why this solution, which at first glance seems elegant, we want 50 total units of pollution. That should be 50 units a firm. That seems like an elegant solution. Why might it be inefficient? So let's go to the math, which means if each firm is given 25 permits, it means they can't pollute beyond that. That's what a permit says. This is the amount of pollution you are able to put forth. And since they can't trade these permits, Previously, each firm was polluting 80 units. In fact, I'm going to put this is just from the given information. I'm going to put this here. So previously, each firm was polluting 80 units. If each firm is given 25 permits and they can't pollute beyond that, then each firm has to abate 55 units. And that's just from the arithmetic. 80 units of pollution previously, the government is allowing each firm to pollute 25 units. That means each firm has to abate 55 units. Questions? So why is it inefficient? We can just plug that into our marginal cost functions. So what I'm going to do is I'm going to scroll up real quick and get our marginal cost functions. Both QA and QB in this situation are 55. We got that just by subtracting 25 from 85. So the marginal cost for firm A at 55 units is 50 plus 3 times 55. We're just getting that from the formula. That's 215. The marginal cost for firm B is 20 plus 6 times 55. That's 350. We're just getting that from this formula. $215 is not equal, this means not equal in programming language, to 350. It costs less for firm A to reduce pollution at this level than it does for firm B. And by forcing both firms to abate the same amount, we haven't induced the most cost-effective solution. It would be more cost-effective to have firm A abate more because it's cheaper, and firm B abate less. I'm going to scroll up. Remember, we set up the first problem to find the social optimum by setting our marginal costs of abatement equal to one another. But here, our marginal costs are not equal. They're unequal. That's why it's inefficient. Questions so far? And again, I'm going to stop sharing and turn my camera on real quick, just so we can check in. You guys with me?
Yes.
All right. So just to recap, all we did was we set the marginal cost of abatement equal to one another. We then set that marginal cost equal to the marginal benefit, being sure to solve for firm A's quantity in terms of firm B. We could do the same thing in reverse. We'd get the same answer. From there, given that we have optimal abatement, we also know how much pollution is optimal for society. Now we want to know, if we have an optimal level of pollution, how can the government dictate the best way to abate this pollution? So let's press pause real quick. Given that we're talking about pollution in this sort of way, can anyone sort of draw any conclusions about implicit assumptions we're making about the pollution? Anyone?
Maybe the rate it's assimilated into the environment.
Right, so we might be making an assumption about the rate of assimilation. We might also be making an assumption about not just the rate, but the geography with which it's assimilated. So I'm going to share the screen again. Oops. Here we say it's inefficient for both firms to pollute 55 units because of the different costs. But you'll note that our marginal benefit function, and I'm going to scroll up again, our marginal benefit function just cares about total abatement, which means we think that pollution is dispersed uniformly. If we were worried about, say, pollution hotspots, we'd probably have a different marginal benefit function that wasn't just concerned with total, but also had a spatial component to it. So we had an inefficient solution if we first forced firms to abate equally. Now, and Christina, I believe this gets at your original question of the math behind cap and trade. Now let's say we're going to distribute pollution permits, but firms can trade them. So before we solve it as a class, I'd like you all to take a minute to try and set up the problem on your own. And what I'm going to do while you set up that problem on your own is bring up the math for part 3 of this question that we just did together. And I'll cut in and say, you can, if you want to answer this question conceptually without formalizing the numbers, you can do that. So I'll give you another minute to think about it, and then we'll come together as a class. In fact, given that we have this Zoom Pro license, let's let you guys talk about let's have some breakout rooms. So you guys can talk about it together. Let's do a bit of a think, pair, share.
Intersect with the marginal private cost, and that would be our social optimum. And so I would just put those two numbers together.
How are you guys doing in this room?
We're good. We're doing calculations right now.
Okay, cool. Well, I'll let you get back to it, and keep in mind that you can sort of answer this question conceptually if you don't want to do it from a calculating approach. But I'll let you get back to it, and we'll come back to the main room in another minute or so. Is everyone back? All right. So who has an answer that they want to share with the group? How can we achieve the social optimum now that we've allowed for trading? Who's got an answer? Or alternatively, who has a question?
I set the MCA and MCB equal to each other to find like a number that, or whatever, to find the social optimum that achieves equal numbers, and I got it as 10. So then each firm will be producing 80 units.
So each firm will be abating 80 units?
Yes.
All right. So I like where your head's at, and an interesting setup. But keep in mind, like what we learned from our different marginal cost function is that we're gonna want to see these firms abate different amounts. And specifically, and this is what I was trying to get you at when I said everyone can answer it conceptually rather than mathematically. If the firms can trade pollution permits, then firm B here, rather than abate at this high cost where it costs them $350 to abate more, firm B has an incentive to buy pollution permits from firm A. So if they can trade, you know, firm B could pollute, let's just, keep it simple. Previously, they were polluting 25 and abating 55. Firm B can say, hey, I'd rather pollute 26 and abate 54. Firm A, can I give you $215, which is cheaper than their $350 that it costs at this level. Put differently, since it costs B more to reduce pollution, they can compensate, they can pay firm A at least that marginal cost, and at most, this marginal cost, to make both firms better off. And this is what efficiency means in an economic sense. Can you make all parties better off without hurting anyone? And these trades will happen up until the point where the marginal benefit is equal to the marginal cost for firm A and the marginal cost for firm B, which is that optimal abatement level we found here in question 2 or question 1. You guys with me so far? Questions? Great. So same problem setup, same marginal cost, same, this is all the given information we had before. But now, rather than a cap and trade policy, can we get to the social optimum using a tax on pollution? And what I'm going to do is put you guys in a breakout room together, and you guys can try and solve this problem together, and I'm going to share a Google Doc with you. So give me 1 second to create a Google Doc. And let's drop it in the chat. All right, so I just shared a blank document with all of you. I'm not sure. Can someone just type something in to make sure that the editing works? I just want to make sure that it's not view only.
It says we don't have edit
It
access.
says view only.
Okay.
Yeah, I can't type anything.
All right. Give me 1 second. No. Okay. Just changed it to edit access, but I'm gonna drop a new link in the chat just in case you need the new link. Okay. So you should all have edit access now. I'm gonna put in this document all the given information. Now you guys, and I'll put you in a breakout room all together. try and solve this problem. And we'll come back in 5 minutes, maybe a little bit more.
Going to reach this amount. So I feel like you can't really reach a social optimum. I don't know if that makes sense, but yeah.
All right, it looks like we're all back in the main room. Who's got an answer? How did the work go? What do you think? Can we use a social optimum, or can we use a tax on pollution to achieve a social optimum?
At least I personally don't think so.
And why is that?
Just because I feel like with cap and trade, I feel like it's more absolute that like we're gonna make this, like we're gonna limit our pollution so we can reach this point. I feel like with taxes, it's just do whatever you want, not do whatever you want, but do what you want, just pay us back or just pay for it. And I just don't see reaching really a social optimum.
Right. So I guess it sounds like you're talking a little bit more philosophically, but we're talking about this from an economic perspective. And all the tax does is, create an outside option. So is it cheaper to pay the cost of abatement, or is it cheaper to pay the tax? So we can really answer this question mathematically. We don't have to say, I think this would happen, or I think that would happen. We can answer from a mathematical perspective. And certainly your point about, behavioral approaches to taxation can be taken into account later once we get the math down, once we set an optimal taxation point. But with an eye towards the question at hand, how might we set up what an optimal tax would look like? What do you guys think? Because really, the approach to the problem is the same way we've approached all these other problems. What have we been doing so far?
Setting the equations equal to one another.
Great job. So we've got the marginal cost for firm B should equal the tax should equal the marginal cost for firm A. But it's not quite that simple. There's one wrench I need to throw in the works, which is the marginal cost for firm B at their optimal level, at the social optimal level, should equal the tax, should equal the marginal cost for firm A at their optimum level. And Christina, to your point, to what you were saying earlier, if the taxation equals that, then they will abate up until the point where they have to start paying the tax, right? When it's cheaper to abate than pay the tax, they abate. When it's cheaper to pay the tax, they pay the tax. That's really the only assumption we've made in econ. Now, from a political economy perspective, from an esoteric perspective, we can talk about what the enforcement mechanisms look like on that tax. But here we're just going through the motions of the mechanics of the math. So we were given marginal cost for firm A. That's 50 plus 3 QA. We were also given QA star is 70. This top equation, that's given information from the problem. This is what we solved for in part 1. Putting those two together, 50 plus 3 times 70, that's 260. Let's see if that holds for firm B. And if that's the case, and it should because we solved for this optimum already, that is the ideal tax. So what we just did was set the marginal cost at the social optimum for firm A equal to the tax. What we're doing now is checking our answer to make sure it's the exact same thing for firm B. So we were given a marginal cost for firm B. That's 20 plus 6 times QB. And again, this was given information. We also solved for the social optimum for firm B. We solved that at 40 in part 1. So 20 plus 6 times 40. That also equals 260. So tax of $260 would achieve the socially optimal level of pollution. Great. Questions? And I'm going to stop sharing the screen and bring up my camera in case anyone wants to talk. All right. So we started this exercise by asking about the math behind cap and trade. And really, we did the math behind cap and trade, and more so, we were able to compare the math behind cap and trade to the math behind taxation. So questions, comments, concerns? And just to recap, we spent Monday comparing and contrasting some of these pollution abatement policies. We had non-market and market solutions. Today, we went through 2 market solutions. We went through cap and trade and we went through taxation. We also went through a command and control style policy, a non-market policy where the government just says you are each only allowed to abate 25 units of pollution. Let's finish this week on policy with a little bit of discussion. Now that we've seen the mechanics of it, the math of it, does anyone have anything they want to add to that discussion, that compare and contrast that we did on Monday?
So whether it's non-market or market, the information that we found, they would both be taxed on either side, or this would just be the tax side, so market.
So taxation is a market outcome or a market-based policy. And the reason why is you are choosing how much you want to pollute, and you are just submitting yourself to those consequences. Whereas a non-market policy would be someone saying, you are allowed to pollute 25 units and that's it. But excellent question. And you'll see how one of the cool things about these policies is, and one of the things that our approach to externalities does overall, is it might solve the problem of missing markets. It might create markets where there were none previously. So if, for instance, we had a cap system where we said everyone is allowed to pollute 25 units, that's not a market outcome, but we might create a market there where I'm allowed to pollute 25, but I don't pollute that much, so I sell you some of my permits, and that's a market. Questions? All right, so that's our hour. Have a great weekend, everyone. Stay safe, stay distant, stay masked. Email me if you need anything. And next week, we have a really cool set of articles that we get to discuss. So I'm looking forward to it, and I'll talk to you all soon.